Have you ever thought about the shape around the world? Why the ball is circle and why, for example, blackboard is rectangular? How we can find an area or perimeter related to those things? Today we are going to talk about it, which is geometry. My name is Mahmoud Kiasari and welcome to Special K. Let's get going. Welcome everyone to today's session, which is about the geometry. So right now in around 30 minutes, we are going to talk about what is geometry, which is the science that we love, and what are we going to do about it, talk about a couple of tricks, examples, and how we can understand better about the area, all of the shapes that we have around ourselves. So without further ado, let's just start. So, geometry, as you can say, based on the name, it's the language of space and shape. So, at this point, we are going to talk about that. What does actually geometry mean? So, as you can see over here, the geometry is the study of shapes, space, size, and properties, and everything related to that. Actually, has a very fun story because it comes from two words. The first one is geo, means earth, another one means metron, or means the measure. So it's somehow, as of most of some kind of the things that we do have in science, comes from the Greek. And after that, we are going to see that how we can use the science in form of math, design, and science, which is our focus over here, is about the math itself. So right now we can see that where actually this word comes from and sort of things. After that, we are going to talk about why we are going to study the geometry, right? Because based on the philosophy that we have about this course and any other related course like this, we are trying to understand it. Then after that, we are going to learn it. Because yes, I know some of you would say that, oh my God, we will have to do it because it's in our school, it's in a university, or it's not anything like that. But let's try to have a bigger picture and see that why we are going to talk about it. So the first thing that we have to know is about the engineer and architecture. As you all know, everything around us is based on shapes. It doesn't matter it's a car, it doesn't matter it's just a normal, some kind of ball, it's a square, anything is based on shapes. So if I want to do something with it, if anyone wants to do something with it, it is so important to understand what are the shapes and what is the science behind this guide and how I can, for instance, find the area, perimeter, or anything related to that. So it doesn't matter in which kind of knowledge or expertise we need that, we all need shapes and geometry itself. After that, we do have about the physics and natural science, as you know, about the computer graphics and design, and almost everything around the world itself. So after that part, let's talk about a couple of important terms that we would start it with points. Again, what are points? As you can see over here, points are zero-dimensional object with position but no size or extension. So as you can see in the picture itself, I do have different kind of dots that I would call it as points. So these points are just somehow we can consider it as the dimensional thing that they don't have any size or extension. We're just there. I mean, right now we don't know anything about them yet, but in the future we are going to learn how we can consider or how we can address this some kind of dots. After that, we do have line. As we know, there is only one line that can connect two dots or 2 points to each other. But we call that specific thing that is going to connect these two some kind of points as a line itself. So line is a one-dimensional object that is going to extend infinitely in opposite direction. As you can see over here in the picture again, I do have A and B, and after that I do have something that I would call it as a line that is going to extend it in opposite direction. After that, we do have the plane itself. What is plane? As you can see again in the picture, plane is the flat surface extended that can extend forever. So it means that it's a two-dimensional surface with infinite width and length but no thickness. Again, it's just like a paper. Yes, the paper itself has a little bit of thickness, but we consider it as nothing. It's only going to be extended, and after that, it doesn't have any thickness in itself. So as you can tell, right now we just learned three important terms. The one is point. Again, it's zero-dimensional thing. After that, we learned about the line, which is about the one-dimensional part. And after that, we learned about the plane, which is going to be two-dimensional thing. The combination of all of these terms that we learned and we have around ourselves is going to create the 3D space for us. As simple as that. After that one, let's talk about the basics. When we are talking about shapes, the very first thing that comes to your mind is something that how I can measure some kind of the distance between these two lines, right? So we do have a concept and we call it as degree. It means that degree is going to be considered as a way that you can measure the distance between two lines. So as you can see, we do have different kind of degrees. We do have the acute angle that we call it as something between 0 and 90. We do have the right angle, which the degree or the distance between those two lines is going to be 90 itself. After that, we do have obtuse angle, which is going to be something between 90 and 180. We do have the straight angle. We do have it as 180 degree. We do have the reflex angle, something between 180 and 270. And we do have the full rotation angle. So from where these kind of numbers come from, actually, from here. As you can see, a full circle consists of 360 degrees. It means that right now I just divided the whole circle to 360 different parts, and I got to consider each of those steps that I do have, and I'm going to move through the perimeter or around the circle, and I would call it as degree itself. Again, this is just 101 of geometry. You don't have to worry about it. But remember, when we are talking about shapes, the very first thing that comes to our mind, especially when we're talking about the circle, as degrees or angles. After that, let's talk about the triangle itself, the very, very first shape that you can see around the world itself. As you can see over here, we do have two different kind of categories. If we would like to categorize our triangles based on the side, we can look at one of these three sections. The first one is equilateral triangle. What does that mean? It means that you do have a triangle. Obviously, we know triangle, each shape with three sides is considered as a triangle. We do have a triangle that all of those three sides are just as the same about the lengthwise. So I do have, for example, my side A, my side B, and my side C, and I would consider that these guys are equal to each other. Another triangle that we do have, an isosceles triangle, is a triangle that has three sides and only two of them are going to be the same. If I consider this one as A and B and this part as C, A is going to equals to B, but they are not going to be equal to C itself. And at the end, we do have a scalene triangle. What is that triangle? It's just like a normal triangle. It doesn't have any rule. It doesn't have anything. Just a normal triangle. There are no same sides together. And if you want to categorize it based on the angle itself, most of the time we are going to look at this specific angle. We are going to look at this angle. We are going to look at the angle. As you can see, there is a point, or there is a section that we would call it as the main part. So at this point, I do have three different kind of triangles. I do have an acute triangle. It means that it has three angles and all of them are less than 90 degrees. This one is 90 less than 90, this one is less than 90, this one is less than 90. And for another one, I do have a right triangle. So for the right triangle, I do have one angle that is going to be 90 degrees. And for the last one, I do have it as obtuse triangle, which has only one angle, is going to be more than 90 degrees. So right now, let's talk about other shapes, because the only thing that we consider right now was about the points, about the some kind of line, about the plane, and after that, very first thing was about the triangle. So what would happen if instead of just only three sides, I have more? I mean, 4, 5, or 6. They also have some names, right? I believe you've seen thousands of them around the world. So whatever shape that is going to be closed, again, any some kind of shape can also be open, right? So when we're talking about the shapes, we're talking about closed things. So if we do have the closed shapes with more than three straight sides, which is considered as the polygons. The triangle itself is polygons. The pentagon, the octagon, the hexagon, and we do have it quadrilateral, which is going to be talked about it, but not that in detail. So each one of these things is going to be considered as polygons. Another important thing that we do have about the geometry is symmetry. What does that mean? For instance, look at this one. Look at this shape that we do have the letter A and we do have E. If I can find a line that draw it over my shape, and if I make it in half and fold the right side all forward one side and fold it onto another side, and if they fit and match perfectly, I would call that shape has symmetry. So at this point, I do have one line that's going to show me the symmetry itself. At this point, I do have another line. So as you can see over here, I can draw the line, and if I fold this half over this one or another, they're going to fit perfectly. Like this one, it also has symmetry. Like this one, it also has symmetry, or other kind of shapes. We do have very interesting things in geometry, and we just learned that we are going to talk about it, by the way. Circle. I believe you can tell me that how many lines actually exist that we can use it in circle, and after that we can say that shape has symmetry. It has infinite number of lines. So as you can see over here, I only have one line. At this point, one line. At this point, couple. But when I'm talking about the circle, I'm talking about the fantastic shape that it can be fold and still is going to be fit perfectly and match. So why we talked about that? Because we are going to use the symmetry a lot in the tiling, the architecture, about any other kind of some kind of jobs there. You're going to see that the polygons and symmetry are two important terms that we have to understand. After that one, let's talk about the circles art, which is going to be considered as one of the fascinating shapes around the world. You see, everything is in circle, right? So when we're talking about the circle, it is so important to understand a couple of different terminology there. As you can see over here, I do have three different names. The first one is diameter, another one is radius, and the next one is circumference. So before just talking about all of those equations, let's talk about these names, let's talk about this terminology. What is radius? Imagine that I'm considering this circle, right? And I'm going to draw a point over here. After that, I would say you that draw a line that is going to move through the center of circle and connect me to another side of circle. Again, you can see that this circle has symmetry, so it doesn't matter if I some kind of fold one half based on another one, they're going to be fit perfect. So as you can see, there is a distance between the first point and the second point. This distance is going to be called as something as we know it as diameter. So the whole distance is going to be called diameter. And if we make it in half, if I tell you that what is the distance from here to here, or what is the distance from here to here, by the way, they are the same, this is something that I would call as radius. Another interesting thing that we have is how we can measure a circle. If you remember, when we were talking about shape, another important part is that how much is around some kind of the shape itself. The circles also has the same thing. So if I ask you to some kind of have a meter, and after that measure around this circle, you can find a number. And that specific number is something we call as circumference. At some points, maybe you heard about the perimeter, which is very, very common in other shapes. But when we do have the circle, we do have it as circumference. Another important thing is about how much some kind of is inside this shape. This is something that we call it as area. It means that how much is the inside space of this specific shape. And also we do have another number, another fantastic one, that we call it as pi. Pi is a magic number, or 3.14159, and this number, it's so infinite. I mean, you can find so many information in the internet or in books about the pi. It's a very, very fantastic number. Try to look at it. It is so good. It's so good for increasing your knowledge. So we do have a number, that pi, that actually is going to connect everything to each other. How? So maybe you would say that, okay, we understand about the circumference, we understand about the area, but how we can find it? Easy. We are going to follow simple formulas. What is that formula? Two things. The first one is this one, which is 2 pi r. By the way, you know that when we are talking about 2 pi r, means that 2 multiplied by pi multiplied by r. What was r? R was considered as a radius, or pi multiplied by d. Also about the area, we do have pi r squared, or pi r to the power of 2. So these were some kind of important information that you have to know about the circles. Again, let's review it. The radius, the diameter, the circumference, area, and pi. The radius is half the line across. Its diameter is the full line across. By the way, when we're talking about the half line and full line, actually, I'm saying that if I do have one point at this place, and if I ask you to move through the center of circle, and after that connect me to another side of the circle, so this is something that we consider as a full line. Another one that we do have is the border length. It means that how, if we measure the whole thing, around the whole thing, how much is that? Inside the space, which is something that we call as area, and pi is a magic number that's going to help us in order to connect all of these things together. Which is going to lead us to another concept, the perimeter and area. First of all, what was the perimeter? Perimeter is just like the circumference in the circle itself. It means that the distance around the edge of a shape. Imagine that you do have a square, and after that I would ask you to measure that how much is the distance around the edge of that shape. This is something that we call as perimeter. Or you can start from here, move, and again go back here. Right now I'm asking you how much distance you have. Another thing is about the area. It's the amount of space inside the shape, which is going to show like this. So let's see a couple of equations. Let's see a couple of useful equations that I believe you've seen it a lot, but let's just review them. When we were talking about the square, and when we were trying to find the perimeter, since we do have 4 different sides, and each of those sides are the same, so I'm going to add them up. L plus L, and I have to do it 4 times. If you remember from the previous videos, when we were talking about L plus L plus L plus L, actually I'm trying to define the multiplication itself. And the area is simple, is going to be one side multiplied by another side. Let's look at the rectangular. So for the rectangular itself, the perimeter is going to be L plus W, if we consider as just a name. Again, these names can be anything. L plus W plus L plus W. Why? I do have one L, one W. This one is L and this one is W. If you do that one, you do have a formula like this. 2 of L plus W, and you can find the perimeter. For the area, just like this square, but at this point, your sides are not going to be the same. One is L, another one is W. We know everything about some kind of our dear friend circle. After that, we do have it about the triangle itself. So about the triangle, first of all, if you want to find the perimeter, you have to find the C itself. Right now, we don't know about it, we don't know anything about it, but in the future, you would see that. Actually, this specific triangle is a very famous one, the right triangle. There are different kind of formulas related to that, but the important one is something that we can find the C. So the area at this point is going to be half of side of A times B. Again, we do have another triangle like this, that's this H is something that we call as height, and B is something that we call it as base. So we are going to multiply by them and divide them together. And after that, we do have the last shape, trapezoid. And at this point, you see that this is a little bit strange shape. So whenever you see a shape like this, that it has 2 lines that are going to be parallel to each other, this is something that we call as trapezoid. So these points, the A and B, are called as bases, And these two lines are going to, or these two sides are going to be considered as lengths. So the area is half of two bases, if you add them up, multiplied by the height itself. So after that, let's talk about the coordinate geometry. That how actually we are going to connect the algebra that we learned from the previous video in the space itself. So when we were talking about the point, I told you that they were zero dimensional. It means that right now we don't know anything about them. And if somebody would say that, okay, draw a point, or after that, show me a point, I would just use a random thing and say that, okay, this is a point. But actually, we are going to follow a very strict rule about that. What is that one? We do have something that we call it as a coordinate plane. As you can see over here, it has two perpendicular axes. One axis that is like this, we call it as x-axis, and another one like this, we call it as y-axis. So why we do have that? Because whenever you're trying to draw a point or find a point, we have to have an address. It's just like here, when you want to go from your home to the bus stop, you have to follow the path, or you have to follow the address, right? That is how Google Map works. So based on that, I have to know what is the address of my point. The address of point has two things. One is about its x-axis, and another one is about the y-axis. We are going to show it like this with two parentheses and one some kind of symbol between them. So when we are talking about the x, if we do have the positive side, as you can see over here, I do have 0, 1, 2, 3 till positive. And after that, if we just move to the negative side, we do have 0, -1, -2, -3, and -4. So based on the place that actually we are going to move, either it's to the right side or to the left side, we can find the address of x. But what about the y? Y has the same concept, but this time it's positive. Is going to be considered as top, and negative is going to be considered as bottom. So whenever you are going to find a point, you have to give me an address. And this address could be anything. For example, it could be +2 and -3. So first, you move through the x-axis. We do have a +2, so +2 would be something over here. And after that, you have to move down there 3 times. So I do have it as -3. So I do have my point right now. So this is something we call it as the coordinate plane. So you can see it has different kind of quadrants. So quadrants means that between 0 and 90, each 90 degrees actually are going to make a specific area for itself. The quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. It's another thing that we call it as origin. It's going to be in the center itself. We do have a very interesting formula. I'm not going to talk about it, but again, if I do have 2 points, for example, one point is over here and another point over here. If I ask you to draw the line between these two, and if I ask you to find the distance between these two, we do have a specific formula for that. Again, we are not going to talk about it. This is Math 101. In the future, when we are talking about the geometry itself, I'm going to consider all of them. And after that, why we do have this plane, but it's going to show us a bridge between the algebra and geometry. And as you can see over here, not only I use the geometry itself, but I also use the algebra to find the distance or anything related to that. So let's talk about the translation. What does that mean? It means that at some points you have to move your shape in a specific way. What does that mean? Imagine that I do have a shape, and after that, I'm going to move that one without rotating or changing it. How? Like this, Jeff. So as you can see over here in this animation, I do have a triangle, and after that, I would like to move it to the right side. I didn't change anything related to triangle. The only thing that I changed was the position itself. This is something called as translation or slide. Another thing that we do have is about the rotation. What does that mean? It means that I do have a triangle, but I would like to turn that around a fixed point, which we call it as the center of rotation. So how, look at this animation. I do have a triangle, and I would consider the center of the coordinate plane, for instance, as the center, the main center itself. And I would tell you that you have to rotate this one 90 degrees. How you would do that? Easy. So you just do it like this. It could be on the left side, it could be on the right side. Again, we are not talking about the advanced part because each of those actually direction means something. But right now, we just try to rotate that one, which is something that we call as rotation or turn. Another one would be about reflection or flip. What does that mean? It means that we do have a shape, and after that, we would like to flip that one across the line. How? Something like this. Imagine that I do have a triangle, and I would like to reflect that one based on the y-axis. Last but not least, we do have dilation, which means that I'm going to resize my triangle itself or whatever shape. At the first point, I do have this triangle, which is the smaller one, and I would like to make it bigger by what? By the number of 2. It means that each of those sides are going to be bigger, are going to be multiplied by 2. So these ones are very, very common way that you can move your shape. But again, you have to follow a path or follow a rule, and after that you can do it. And at the end, we do have something that we call as a 3D in geometry, right? Everything that we were talking about it was about actually 2D. So what would happen if I do have 3D, some kind of area, like the cube, like a square, like a cylinder, like a cone? We also do have different kind of formulas for that, as you can see over here. Again, I'm not going to talk about them in detail, but something that I would like to talk about it is about the symbols. So when we do have, for instance, let's talk about the cube itself. The formula for cube, the formula for the volume, but before that one, what is the volume itself? The volume is the inside space, right? In the two-dimensional, it was easy because you only have one plane. It didn't have some kind of length itself. But right now, it's going to be a little bit more challenging. Again, we do have the area inside this one sphere, the area inside this one, the area inside this one. Another thing that we do have is about the surface. Surface means that the area, surface means that the around the shape itself, the total area of all faces. For instance, I do have a cube, and we know that this guy has 6 faces. So I have to find some kind of the area of each of those faces, and after that add them up. So this is something that we call as a surface. So when we're talking about it, for example, cube, the volume is s to the power 3, right? So what was s? S means that the side of each length. I do have the cube itself, and each of those sides has a length itself. And after that, we do have sphere. So sphere is v is equals to 4/3 times pi times r to the power 3. Again, those are formulas. You have to memorize them, or you have to use the cheat sheet for that. R is the radius. Again, radius is just like a circle. As you can see, square is the 3D form of a circle, which was 2D. After that, we do have the cylinder. The v is equals to pi times r to the power 2 times h. So what is the r? R is the radius. What is the radius? Again, as you can see, 1 or 2 faces of cylinder is circle. So r is the radius of that, and h is the height of this specific cylinder. And at the end, we do have the cone itself. So the volume would be 1/3 of pi r2 times h itself. Again, what is r? R is over here, and h is over here itself. So at this point, we were talking about some kind of the knowledge of geometry, and we talked about different kind of things. What are the different shapes that we have around the world? What are the related formula? What are the related terminology that you have to understand? And in the future part, when you're talking about the geometry, because right now this geometry is part of Math 101, so I didn't want to open up that much. I didn't want to talk about it in detail. But in the future, when you're talking about the geometry, actually we are going to talk about in detail where we do have those formula from, and how we can use them, in some kind of specific point, and any other kind of related thing. Again, thank you very much for being here with me. My name is Mahmoud Kiasari. Have yourself a great day, night, whatever. See you around.